All right, it's on.
Okay, sweet.
All righty. So, lesson 17. How'd you like the lesson 17?
Everything looked pretty good so far.
I mean, it's pretty short. I think it's like almost the exact same as 16 with like the proportions and the confidence. And though we already learned that, and then like it's pretty. I mean, it's pretty like I thought it was pretty straightforward.
Yeah,
Um, so should we just get at it? Because
yeah,
I have to,
yeah.
get um open
So
it.
1 and 2 are true. And 3, the symbol of the true population proportion is which of the following? That's P.
Yep, I agree with that. That's a population proportion. Okay, so just regular P, right?
Yeah. The
Um,
requirements for constructing a confidence interval are
so
satisfied.
with the confidence interval, I remember the two requirements thing. It's like n times p is greater than or equals to 10, and then n times 1 minus p is greater than or equals to 10. Um,
So n times P is greater than yes. And
yes,
what was the second one?
and then in brackets 1 minus p.
1 minus P. Yep.
E, n times p, yes, n times 1 minus p, so zero point 0.9. So with the confidence interval, it's the p with the hat, but with the hypothesis test, it's the regular p. So it would be 1 times zero point 0.9 is zero point 0.9, which is, wait, 1 minus 1 minus p, which is 1 minus zero point 0.1, right?
It was 0.9.
zero point 0.9.
Well, 1 minus, is it P or P hat?
P, so for the confidence interval, it's p hat.
Okay. So it's 1 minus zero point 0.1, which is 0.9.
0.9. So 1 minus zero point 0.9 is not equal to or greater than 10. Nope,
So it's false.
it's false. Because that's for the confidence interval. Um, yeah, it has to be and, so it has to be both. And then n times, so 100 times zero point 0.1 is 10, which is good. But oh no, sorry. N, no, it's n times 1 minus p. So it's 100 times 1 minus zero point 0.1. So 100 times zero point 0.9, which is 90, which is true.
Okay, cool. Okay, a study of first-degree murder trial was conducted in another state. Random sample of 60 people on trial. Of these, 45 were not guilty. Were guilty. Find p hat, the point estimate of the proportion of first-degree murder deaths.
So p hat is it's x over n. I remember that. So it's 45 over 60, which is what is it? 0.75?
0.75. Yeah.
Yeah, 0.75.
And then
So
create a
point
95% confidence interval for the true proportion of first-degree murder trials in the state. There's a verdict guilty.
oh, it's that equation. It's that long equation.
So it's 45 out of 60.
So it's 45, but so it's the equation of p hat minus z score to the square root of p hat times 1 minus p hat over n.
Okay, let's calculate
And then
that.
the other one's plus. So one's minus and one's plus. That's the lower and upper bound. So do you want to calculate real quick and then let's see if we get the same answers?
Yeah, let me get that.
So it's
Okay, it's time.
Okay. I'll come over as soon as I'm done. Okay.
Wait, I
Did you
almost got it. Wait, I almost got it.
Dang it! They're stuck on those ones.
Oh, dang it, I made a mistake. Give me 1 second.
No, can't agree. And Jesse's out the door.
I don't know what you got, but I got for the lower one. I got point 0.640433. So it's I think it's C.
Yeah, that's what I got.
Yeah. Okay, sweet. That's the only one with the 0.640.
Yeah.
Okay.
If you increase the sample size from 60 to 80, what do you expect to happen to the width? The width will decrease when you increase the sample size.
I agree with that. Yes, because yes.
Yes, because yes.
That's so valid.
Yes. Thanks. Wait. So, right? Wait. The width. Yes, because with more sample size, with more n, the the intervals will decrease because the answers it'll be more accurate, so it'll decrease. Yes. Yes, I agree.
To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P is 1/2. What is the smallest n can be and both requirements still be met?
So it'll be n times p is greater than or equals to 10. So if p is 1/2, n has to be at least if p's half, n has to be 20 to make it equals to 10. And then the other one's n times 1 minus p. So if 1 minus 1/2 is 1/2, and so 1/2 times what is equals to or greater than 10.
So if that one is 1/2, then the next one, when it asks for 1/10, it has to be 100, right?
20. Well, no, it'll be 20 because if p is 1/2, then n has to be at least 20.
Not my reason. Yeah, and the next one would be 100, right?
Yeah, because it's the same equation. It's n times p greater than or equals to 10, and then n times 1 minus p is greater than or equals to 10.
Thank you.
So yes, wait.
Yeah.
So 1/2
For the
times 20 is 10. 20 times 1/2 is, yes, 10. So the number 9 is right. Number 10, if it's 100, then 100 times 1/10 is 10. And then 1 minus 1/10 is 9/10. 100 times 9, yeah, so it's 100.
Yes.
Okay, use the watercolor study about 60% of the macro-invertible. How should it be?
It's decrease and conduct a hypothesis test using the sig level of 0.05. They collect the new data, and this time n equals 80, x equals 38.
Just have Brayden bring one. Wait.
For the conducting a hypothesis test are satisfied.
Here, we'll bring two.
So we do, let's see. So,
Yeah, this is a mess.
What the heck? Wait, give me 1 second. We use that equation, right?
I'm pretty sure.
Yes. It's believed that 70, blah, blah, blah. Okay. So then we do,
Are you guys going? Yeah.
Yeah, I'm just finishing this call.
is believed that 0.7. So we use 0.6. So for P we use 0.6. So it's 80 times 0.6 is equal to the greater than 10. Yes, that's true.
True.
80 times 1 minus 0.4 is greater than or equals to 10. Wait, sorry, 80 times 0.4, yeah. What's 80 times 0.4?
80 times 0.4. It's 32.
What's up?
Yep. So, yes, it is true. They're both satisfied.
Okay, what is p hat? I'll calculate p hat. You calculate p value.
What, you mean test stats?
Oh yeah, and then I'll do test stats.
No. Okay. So are you doing p hat and test stats, and I'm doing p value, or what? Because the
Yeah.
first are okay. You're doing those two. I'm doing 14 then. Okay.
Love me too. Yeah, I'm fine. Alright. Alright, awesome. Right.
Well, did you end up marrying Prince Jack or no?
Yeah.
There's a difference right now. Three. Oh, you're perfect. I love you.
I love you. Yeah. No,
I need to take school next night? Yeah. How many?
Just take one. Rachel and I are both taking one.
How many do we need? We don't know.
JC just said bring a couple, so everyone's just gonna bring one.
Okay, I got 3.
No,
Okay.
just bring one, please.
Take 2, because I can't take one. I got these.
Because we just need to bring a couple. So I'm bringing one, Rachel's bring one, Brandon's bring one. Okay, I got p hat.
Okay.
And the test statistic.
Yeah, I think I got the p value too. Okay. I think I
Okay, p hat, I got 0.475.
0.475. Okay.
And then test statistic, I got negative 2.282.
Negative 2.282, you said?
Yeah.
And then the p value for this test is 0.011.
Okay. What is the decision for this test?
So since the p value is lower than the significance level, because the sig is 0.05,
So they reject it.
yep, reject the no.
And since they reject it, it's sufficient evidence.
Yes.
And blah has not
Yeah, sufficient evidence.
decreased.
Yep.
Okay, sweet. Let's turn this in. Submit quiz. Yes.
Alrighty.
Nuggets. Okay, sweet.
Alrighty. Okay, I gotta run.
Yeah, me
But
too.
have a great week. I will see you later.
Thanks. Have fun on your island.
Thank you. Okay, bye.
Okay, bye.